Today, I want to talk about a very important topic in financial risk management: value at risk versus conditional value at risk, also known as expected shortfall. Let us start by assuming that the returns on portfolio are normally distributed with a means mu and standard deviation of sigma. Now, what does value at risk means? Suppose we choose a confidence level of 95%. Then value at risk is the return level such that there is only a 5% probability that the portfolio return will fall below that level. In other words, if we draw the probability density function of the returns and integrate the area under the curve, then 95% of the probability mass lies above the value at risk and only 5% lies below it. So, only 5 times out of 100, the returns on our portfolio would be worse than the value at risk. Now, what is conditional value at risk? Suppose we are already told that the portfolio return is worse than some given threshold. In our case, let us suppose that value is C. Now, the next natural question would be, given that we are already in the bad tail of the distribution, what is the average loss we should expect? This is what conditional value at risk or expected shortfall measures. It is defined as the expected values of the returns below given cutoff. To make the calculations easier, we convert our normal distribution to a standard normal distribution. We define Z as returns minus the means divided by the standard deviation. Now, we do the same thing for our given threshold level, where Z0 is equal to C minus mu divided by the standard deviation sigma, so that our distribution has a means of 0 and a standard deviation of 1. We now want to compute the expected value of Z given that Z is greater than Z0. By definition, this conditional expectation would be the integration of Z times its probability density function divided by 1 minus the cumulative distribution function at Z0. Now, as it turns out, the integration of Z times its probability density function from Z0 to infinity is equal to the probability density function value at Z0. So, in essence, our expected value of Z, given that Z is greater than Z0, becomes probability density function at Z0 divided by 1 minus the cumulative distribution function at Z0. Our expected shortfall in essence should be the expected value of Z, given that Z is less than the given value of Z0. But computing that could be fairly complicated and a difficult mathematical task. So, to summarize, value at risk tells us the point where the worst 5% of the outcomes begin, and conditional value at risk tells us the average size of those worst case outcomes once we are already in that 5% tail. This is why conditional value at risk is often considered more informative risk measure than the value at risk. This is a small reference material which I took from the book A Course on Statistics for Finance by Stanley L. Sklobe. Thank you.